Dear students, welcome to this session on the topic electrochemistry. We are going to discuss transport number, anomalous transport number, and to obtain relationship between ionic conductance and transport number. So in electrolyte solution, flow of current will be due to migration of ions to the oppositely charged electrodes. So current will be carried by ions. So the fraction of total current carried by an ion is termed as its transport number or transference number. The current carried by an ion will be proportional to its mobility. So if the velocity or speed of the ion will be more, then more amount of current will be carried by the ion. If U plus is the mobility of cation and U minus is the mobility of anion, then the transport number of cation, that is current carried by the cation to the total current, that is the fraction of current carried by cation will be equal to, so current carried by ion will be proportional to its mobility, so it will be U plus upon total current is proportional to sum of mobilities of the ion. So U plus U minus. So this is the expression for transport number terms of ionic mobilities. Also transport number of anion will be fraction of current carried by anion given by current carried by anion to the total current. So it will be T minus will be equal to U minus, that is ionic mobility of anion, and total current U plus U minus. So this is the expression for transport number of anion. And if we see the expression, the sum of T plus and T minus will be equal to 1. So if we know the transport number of cation, we can calculate the transport number of anion and vice versa. So now coming to the anomalous transport number, also known as abnormal transport number. So any deviation from the normal will be anomalous or abnormal. So the transport number is found to vary with concentration of the solution and temperature. So the transport number of cadmium ion in cadmium iodide solution will be normal in lower concentration solution, but it is found to decrease abnormally with the increase in the concentration of the solution. So if we observe these values, as the concentration increases, the transport number of cadmium ion is found to decrease almost nearly to 0. So cadmium ion at lower concentration moves towards cathode, but at higher concentration cadmium ion migrates towards anode, and thus transport number decreases. So this decrease in transport number or the migration of cadmium ion towards anode is due to the formation of the complex ion carrying negative charge. It is at higher concentration. So at higher concentration, cadmium iodide will dissociate ionizers to form complex ion. So the decrease in the transport number is due to formation of this complex ion. Now let us see how to obtain the relation between transport number and ionic conductance. The transport number of cation and anion is given by the expression, so T plus equals U plus upon U plus U minus. So transport number of cation and transport number of anion will be equal to U minus upon U plus U minus, where U plus is the mobility of cation and U minus is the mobility of anion. So transport number is the fraction of current carried by an ion. So ionic conductance at infinite dilution is proportional to its ionic mobility. So lambda naught plus, that is ionic conductance of cation at infinite dilution, is proportional to its ionic mobility U plus. Similarly for anion, lambda naught minus is proportional to U minus. So now in this expression, so we can substitute for U plus, that is lambda naught plus, and for U minus, lambda naught minus. So if we remove the proportionality constant, which is equal to Faraday's constant, so in the numerator as well as in the denominator it will get cancelled. So transport number of T plus is equal to lambda naught plus upon lambda naught plus plus lambda naught minus, and for T minus will be equal to lambda naught minus upon lambda naught plus plus lambda naught minus, that is sum of ionic conductance of cation and anion at infinite dilution. Also, from Kohlrausch's law, we know that the sum of ionic conductance of cation and anion at infinite dilution will be equal to equivalent conductance of an electrolyte at infinite dilution, denoted by lambda naught. So in the denominator we can substitute for lambda naught. So the transport number of cation will be equal to lambda naught plus upon lambda naught, and for transport number of anion will be equal to lambda naught minus upon lambda naught. Thank you.